This is 7.3. It's sampling distributions for proportions. So those of you that did not like 6.4 or the buffer one with the binomial, here's your second chance to be able to do this. So sampling distribution for a proportion. All right, what's that? What is a proportion? Okay, essentially it's just a percentage. That's what you kind of got to think about this as. So I'm going to call this p hat. All right, I know some of you are like p caret or whatever you want to call it, but I like p hat. So the hat's on the p's head. Okay, and what you're going to do is, how to calculate this is just your percentage. What we're looking for over the total. Everything gets divided by n in this section. So everything you've thought of before with binomial essentially is exactly the same, except you divide everything by n because it's a proportion of your data. So it's kind of like an average. What are we looking for? So what did we have to check in 6.4 to continue in order to go from binomial to normal? Or use your normal table. You had to check these two clauses. As long as n times p and n times q are greater than 5, you can proceed. What's different? This is a proportion section. So back in 6.4, or binomial if you remember, it's n times p to find your mu, right? Well, we're going to divide it by n. What happens? Everything gets divided by n. The n's cancel. What's left? Just your probability of a success. So in this section, and this is a formula right on your formula sheet, here's your mu for p hat, or your proportion. The average or the mean for your proportion is just the probability of the success. Now the standard deviation is a little bit different. Now I'm going to try to show this quickly using a little bit of algebra. Back in chapter 6, your standard deviation was the square root of n times p times q. In this chapter, you are dividing everything by n. Well, what happens? Using not so much, using kind of a little bit of algebra, if you try to follow me here, I'm going to break off the square root of n on the top. And if you take the square root of n divided by n, okay, all that's going to be is, if you think of n to the 1/2 power, p, q on bottom, and then n to the first power. If you divide that out, you're going to have 1/2 on the bottom. And the n to the 1/2 is just the square root of n. So I have square root of p, square root of q over the square root of n. Some of you are thinking, oh my goodness, what's going on? I'm trying to show you why it's p times q over the square root of n. I now can put this under one radical. So there's the algebra, or the proof if you want. If you don't want to think about the proof, just go to your formula sheet. This is the very last formula in chapter 7. That's the standard deviation for your proportion, or your p hat, or the binomial problems that you're going to deal with. So there's how you find your mean. Here's how you find your standard deviation. And then we're going to use these scores and we're going to do the same idea. So standard error, I just talked about it. Square root of your standard deviation for these proportion problems, p times q divided by n, and take the square root of it. Now in the binomial problem, some of you are like, oh, I don't remember how to add 0.5 or subtract 0.5. Here's your chance to do it again. The continuity correction still stands. We're going from a discrete number to a continuous variable, so we are going to have some error involved. Okay, what is the error? Okay, we need to add not just 0.5. What did I say we have to do with everything in this section? Divide it by n. You will divide 0.5 by n to the either left or right side, away from the stuff we're looking for. So I'm going to go through a problem like this, but just remember we got to divide 0.5 by n every time. So here's an example. Let's go right to a concrete example to see if we can figure this out. Suppose the annual crime rate in Denver is p equals 0.111. So probability, and if we think of a success as a crime rate, actually committing a crime is a success. I know that seems oxymoronish. There's the success. If you ever see this in a problem, instantly binomial, instantly got to think the last two formulas on your chapter 7 sheet. So if 50 people, there's your n, live in an apartment complex, what's the probability that between 10 and 20%, So what's going to happen is what you're looking for is going to also be a percentage because it's a proportion. Okay, they're not going to look for 30 to 40 people. They're going to look to 10 or 20%. They're not going to give you a concrete number. They'll give you a percentage. Before you can continue, check your conditions. Remember, your conditions are n times p and n times q. As long as they're both greater than 5, you're good. And in this case, they both will be good. So we can approximate our proportion, whatever we're looking for, the 10 to 20%. That's what we're looking for, with a normal distribution. Okay? So what's going to be our mean and standard deviation? Because in order to get a z-score, I need both of these. Well, your mean is just your p-value. It's straightforward. It's actually really easy. This is about the easiest section there is once we grasp it. What's your standard deviation? Square root of. Now remember, p is what's given. Essentially, your mean is going to show up again. Q is what's left over. These two must add up to 1. And then divided by 50. Do the inside first, then take the square root. Here's your standard deviation. Now, we want to look for the probability between 10 and 20%. Since we're going from a binomial to normal, this continuity correction has to show up. So those of you that struggled with this in Chapter 6, here's your chance. You will add or subtract, depending upon what we're looking for, 0.5 again, divided by n. In this case, it's 50. If you go 0.5 divided by 50 on your calculator, you will get 0.01, or 1%. So we're going to give a buffer of 1% each direction. So since this is an interval, the left side must go left, the right side must go right. So I'm going to subtract it from 0.1, or 10% becomes 9%. And then the 20% I need to go up, so that's 21%. So this is actually what we're going to look for. That's what we're going to use to get our z-scores. So I need to find the z-score of each. So I put these in the actual intervals. So you're going to do this one first, or separate. The 9% minus your mu. Remember, your mu or your mean is 0.111. Your standard deviation we found on the previous page, 0.044. So this is no different. A normal z-score, you all have done the rest of this before. And then you do this one, separate. And then since we're looking for between them, or an interval, you're going to actually subtract them. Okay, so go in and find the probability of 2.25 and the probability of negative 0.48. If you subtract those probabilities, you will get 0.6722. And now you've done all that enough. I'm going to assume that you can do this. That you can go into your table and get 2.25, the probability, and also go into your table and find negative 0.48's probability and subtract them to find this answer. Now, since this is kind of a word problem, we need to start answering them. So we need to start getting in this habit. So in section 7.3, I'm going to have you write out a sentence to explain what's going on. There's about a 67% chance your answer, and then tell me what that means. What are they looking for? What was the original problem, basically? That 10 to 20% of the residents will be victims of crime next year. So basically you took your original interval and rewrote it in words. This is what I'm going to be looking for on your test. So about 67% chance between 10 and 20% of the residents will become victims of crime the following year. So there's one concrete example for you. There'll be a bunch of them in the homework for you to look at, and then I also will help you out in class when I get back. The last part of this section, hopefully you brought your books home. I want you to open to 384. I'm just going to show you this quick. Now, I also talked about this when I gave the test back, that control charts for proportions are essentially a spit-and image of the control charts from Chapter 6. So if you're able to do control charts with the mean in the middle and 2 and 3 standard deviations up and down and graphing them, it's exactly the same idea. So on this page, this gives you the big, whoa, what is all this mumble-jumble stuff? Basically, all this means is calculate your mean. All right? Total number or total number we're looking for over the total number period. And then 2, notice this is your standard deviation, standard deviations, and 3 standard deviations up and down. And then there are 3 control signals again. They're all the same. Okay? 1 point, any 1 point beyond 3 standard deviations. 9 consecutive. 2 of 3 consecutive points beyond 2 standard deviations. All of this is the same as the last chapter. So here is the actual ending control chart, or what we call P-charts, because they're proportion charts now, for the example 6 on page 384. This is the picture on the top of 385. This is 385 right here, this table. So what is significant about this? If you read the problem, they calculate, okay, what's the probability? So you either can figure out what they all are because there's probabilities on the bottom of the table, or you can add up the actual numbers and divide by the total. However you get there, your average is 0.7 or 0.175. And that's that middle line. Alright? And then notice there are 4 other lines. 2 standard deviations, that's what this means. 2 standard deviations. 2 standard deviations above, the standard deviation is 0.049. So your mu is 0.1750. Your standard deviation is 0.049. That's on the bottom of page 384. And if you multiply that by 2, that's almost, well, 0.1 up. So if you look at it, I'm just shy of 0.1 up. That's why that number's there. And then if I add another 0.049, that's how I get here. And then you can subtract almost 10%. And then another almost 5%. And that's where these lines come from. And then they put in the number of A's. That's what this is talking about. Number of A's in anatomy and physiology each semester. So there's like 12 semesters straight. And they calculate what percentage of the students got A's in it. Alright, and then are there any out of control signals? So the 3 of them are, is there one above or below 3 standard deviations? And that's why they have a 1 here, because it's out of control signal 1. All I would want you to tell me is that yes, one semester there were over 30% of the kids that got A's in anatomy and physiology. Why, if the rest of them never had that? Is it just an extremely bright group of kids? Did the teacher teach better? Easier grading? What was the scenario? We don't know. So they might want to look into that, being as though the other 11 were not even close. And are there any others? No, there are not any others, because nowhere in here are there any other points even above 2. So that means 2 of 3 cannot happen. And then we do not have 9 consecutive points above or below the mean. So that means that one's not out of control either. So there will only be one out of control signal. So out of control. Which one is it? 1 point above 3 standard deviations. And then you could put what semester that is if you know what number that is. I think it's number 13 or no, number 12. So semester 12, if you really wanted to list, you know, which one it is, that's what they would look for. So this is no different. So hopefully you can practice one more example and get familiar with it. Hopefully it's not completely new. And then hopefully you can do well with these problems in class, and I will try help you out when I get back. I hope you guys have a wonderful day.